Hello, this is Max Rack. I just want to talk about, we've been doing this ephemera stuff and things, and on this one here, we did the timetable. Now, if we just zoom into that timetable, one of the things that sort of I asked a question when I was looking at it is when I was calling stuff from the API, I get the high tide is 0.47, the low tide is minus 0.42, the high tide is 0.33, the low tide is 0.37. So it seems as if they were sort of working from a mean sea level, and then it was giving me the high tide from the mean sea level and the low tide from that. When I looked onto the this tide table through here, this one goes, high tide here is 1.6 meters, low tide is 0.7, high is 1.5, low is 0.8. So I was suddenly thinking, well, all of these are positive numbers, so it must have a different datum. So I was a bit intrigued by the datum. So I sort of ended up going two ways. I sort of ended up going to the big picture stuff with tides, that I just want to talk about some of the things there. Then I want to go into some stuff on local stuff. Then I want to go into doing a little bit of web scraping to grab this data through here. So we're just going to go back. I found this nice little image through here that does an example of the tides and the gravity, the moon pulling on the earth and actually pulling the tides out. I still can't figure out why they go out the back. I suppose because it's squashed in the middle and it oozes both sides. And then the different ones, which ones are high tides and which ones are low tides through there. And then the solar ones where you get a spring tide and a neap tide, depending on which ones you are, and then what the moon looks like from the earth when those events happen. So this one here's a neap tide when it's half and half. So I thought that was a nice little visualization. This was just another one on springs and neap tides. So that's your main influences. So the bit from that point, I suddenly thought, well, how strong are the tides, and how much influence do planets have on the tides? So I started to do a bit of typing in Firefox and just saying, hey, you know, what about planets on tide? And there was nothing there. So in the end, I went and asked Bing, and I said, hey Bing, what's the gravitational force between the Earth and the Sun based on distance, and the same for the Earth and the Moon, and also between, say, Earth and Venus? So it gives me the formula and does all of that, and it says, okay, then the average force from the Moon is 1.98 times 10 to the 20 newtons. And then it said, well, the force from the Sun is gravitational force from the Sun is 3.52 times 10 to the 22. So I started thinking, well, wait a minute, that Sun's magnitude is another 100 times more than the Moon's magnitude. So I put some numbers in and I said, well, that would infer the Sun has more influence on the Moon, on the tides. Its gravitational force is 170 times as strong. And he said, well, it's true that the Sun's gravitational force is stronger than the Moon's due to its larger mass, but the Moon has a greater influence on the Earth's tides. This is because the Moon is much closer to the Earth and the Sun is, and the strength of the tidal force decreases rapidly with the distance. It's inversely proportional to the cube of the distance between two objects. So that means there's a massive drop-off using the cube. So if you've got a number divided by 3, the cube, so it's a cube root of the thing, it's pretty impressive. So I said, well, can you give me comparative forces of the Moon and Sun influence on the tide behind that? So he went and did a little bit of math, but he came up with the Moon's tidal force on the Earth is roughly 1.1 times 10 to the 20 newtons, and the Sun's tidal force is approximately 5.05 times 10 to the 19. So just looking at that, one's 20 and one's 19, so it's about, and one's 0.5 and one's 1, so we're talking about one's about 2. So dividing one by the other, so the Moon is 2.178 times the magnitude. So it's starting to think, well, okay, then that comes back. In my previous video, I'd found somewhere where it says roughly the Moon is 2.5 times as strong as the Sun on the tides. So this sort of comes into the numbers that I want. So I can then finally ask myself, well, what about Venus? So I said, well, right, I can then take Venus when it's closest to the Earth and take Venus when it's the furthest from the Earth. When Venus is the closest to the Earth, how much influence does it have on the Sun? So it's using the same sum here. F is equal to 2 times g times m times 1 mass times second mass divided by d, the distance, to the cubed, and it's divided by that. And it said, well, Venus, based on all of those numbers through there, is 2.46 times 10 to the minus 10. So that means it's a magnitude of 10 to the 30. So it has no influence at all. It is negligible. But as I was doing that, there was when I was searching some stuff around for this, I came across a couple of things as well. One of them was this idea of the regression of the lunar node. This is worth watching. He uses a tennis ball as an example of that. And basically, this is when the moon is closest as ever. The moon's doing an elliptical orbit around the Earth. And every 18.6 years, that's when the moon is its closest to the Earth. And so that's when you're going to get the highest high tides and lowest low tides and stuff. So that has an influence through there. What else has an influence through the things? Well, there's also the thing of how the land masses actually relate. And one of those is that suddenly you get these really weird tides as well. So like New Zealand, we've just got perfectly semi-diurnal. So therefore we've got a low tide, and then we've got a high tide, then we've got a low tide. And they're roughly on the same sort of heights. But inside I've forgotten where it is now. Down below Texas and around Puerto Rico and all of those, they've only got a single tide, high tide, and a single low tide. And then you've got these mixed, so you've only got one diurnal tide, and then inside, there we are, Gulf of Mexico, it only experiences one tide a day. And a lot of them actually have these weird, so you've got a real low, and then you've got this little high, and then you've got a little low, and then you've got big high. So you've got these kind of mixed semi-diurnal ones. So New Zealand and part of Australia has a whole mixed bag of that, and I'm not too sure. But one of the things could be influencing some of these is the next thing along, which is the Coriolis effect. So depending on where things are, where land masses are, they're sort of blocking the tides just flowing around the Earth where the water is, so that the tides are just consistent. So on this one here, it takes the Earth 24 hours to rotate one time. Now if you're standing a foot away to the right of the North Pole, so that's 300 millimeters, or South Pole, that means it would take 24 hours to move in a circle that's about 6 feet, so 1.8 meters circumference. This is about 0.000005 miles an hour, so very, very slow. Now, if you go down to the equator, it still takes the Earth 24 hours to make one rotation, but the entire circumference at that point is 25,000 miles. So that means that you're travelling almost 1,040 miles per hour just standing there. So we take this example of you've got two trains, and you're throwing a ball directly north from the blue train to the red train. Now, if you've got a train that's on the equator and then one that's on the Tropic of Capricorn and one on the Tropic of Cancer, say, if you try throwing the ball either north or south, it will start to curve in one direction or another. So if you're throwing it to the north, it will start curving clockwise. If you throw it in the south, it will start curving anti-clockwise. So this is the fact of different distances on a sphere. So you would see this if you actually got a sink. You're draining water out. If you're in the south, if you're in the southern hemisphere, you'll see that the water rotates down the sink anti-clockwise. Whereas if you're in the north and you drain your water, it'll rotate clockwise. So that force is actually causing the tide to, although it's actually being pulled at one point in time, there's also a swirl, and land masses are sort of blocking things up, so they cause a bit of confusion in there. So they're causing some interference from that point of view. Another thing that actually influences tides as well is the meteorological effect of the tides. So you've got your barometric pressure. So it's sort of like inverse barometric pressure. So if it's a low pressure, you're going to get big lifts in the water. If you've got High pressure is going to flatten it out. So it's often described as inverted barometric effect. You can also get the wind that actually has some effect on the stuff. So this is a sort of the wind blowing over, and as it's rubbing on the side of the water, so you've got that interference plane through there, it's actually adding force from the wind into the water, so it's causing waves. Now, depending on the reach, so depending on, there's no obstructions and things like that, and the wind is steady over a long period of time, that will actually have a major influence on actually making bigger and bigger waves. So you need that reach, and you need a certain velocity in a way, and you need it to be reasonably uninterrupted, so not big land masses in the way to do that. So combined with both the barometric pressure and the wind, you can also get these storm surges. Now, when I was watching this video, he was suddenly saying that, in fact, you can get up to 2 meters difference because of some of the meteorological things actually happening through there, maybe even more. But, you know, that's just because of the pressure, maybe. So there's all these other influences that are having major influences on your tides overall. Now, when I actually came to look at the tides in New Zealand, one of the things that made me, and this was when I was looking at the datums, suddenly there's not just one datum for the sea level or whatever all the datums are. There's a datum for Northland, there's a datum for Auckland, there's one for all these different areas, one in Wellington. So it's quite strange. So you suddenly think, well, why that? And then you say a lot of it's to do with ports. So, and they actually have, this is another thing, they've got one peg in a location where they measure it from. So it's always from a certain point. So I suppose you can actually get uplift or earthquakes or things like that, which you do get in New Zealand, such that there'd be a settlement. So maybe things have to be remapped. So they've got to get the surveyor out there with his tripod, and he's got to go and do some measuring as well. So when I actually looked at the one for Wellington through here and clicked on that, this is the location of that one, and it was actually pegged in, I think, 1958. So, and it says vertical datum. It's got one from 2016. It's got one from 1953. So I think they've the peg still stay, but I think they've adjusted where the levels are for some of their other datums. Anyway, coming back to that, I suddenly thought, well, where is this peg? Where's me peg? And I had that before. Where's my peg? And the actual peg of where it is on the corner of Lambton Quay and Featherstone Street, which is downtown Wellington, right in the middle. But when we look at where it is compared to where the coast is, it's miles away from the water. Although Lambton Quay was the original coast when the settlers first came in the early 1800s or whenever they came over here. So I suppose they're trying to put it on rock that was on not on reclaimed land, so that it's not going to settle much from that point of view. But the thing that amuses me is there's bloody great big buildings in the way, so you can't even see where the tide is from that. But that's where it is at this point in time. So I thought that was quite interesting. So in all of the standard port tide tables. So ports are quite important, I suppose, from the point of view. You need to know where your tides are, especially if you've got boats with deep hulls or they're overloaded, so that they're not going to get stuck on land, and they know that even when they're coming up to the piers, they've still got enough draft underneath so they're not going to get stuck. So in Wellington, there's a whole lot of standards that they have for these, so that they go and get the surveyors out there once in a while to measure. So there's these MHWS, which is mean high water spring tide, mean high water neap tide, spring low water neap tide, spring high water, and then you can see the range between the stuff. So we got the spring range and the neap range. Then we got the mean sea level. So the mean high water spring tide is the fact that if we go back to here, you see for each day we've got 2 high tides, so it's the average of those. So that's where the mean high water for that particular day or whatever, and they just take it over a bigger average, the same. So it's not, you're always going to get one slightly higher and one slightly lower, so they're just taking the mean as much as they can through all of these through there. Then you've got the mean sea level, and then you've got a hat and a lat. It would be nice to have a hat and a cat, but it's a hat and a lat. And what the hat and the lat are are highest astronomical tide, hat, and lowest astronomical tide. So these occur every 18 years. So we know about that. That's when the moon's the closest to the Earth, so that's when it's pulling the most. So when we actually look at this, we got the mean sea level. So we got the mean sea level, which is calculated from the neap range of the mean high water neap and the mean low water neap, and also from the mean high water spring and the mean low water spring down here. And then we have the hat, which is the highest astronomical tide when the moon's the closest, and the lat, which is the lowest astronomical tide. And the interesting thing, which it never occurred to me, but it's quite logical really, is that all the tide charts or all the chart tables for all the nautical things are set from the lowest astronomical tide. Because if you set it at the mean tide, and there's this big rock just under here, and then suddenly you go sailing along thinking that we're all okay, but you're actually on the mean low water, you can end up clonking it. So if you take it from that point in time where it's the lowest, and anything sticking out of the water at that point in time, then you're suddenly thinking, well, you might not notice it at this point in time, but you've seen there's something there, so you're going to be a bit more careful. So it makes sense. I sort of notionally, we're not thinking about it that much, that in fact, the chart tables would always be from the mean, but it makes absolute sense to start it from the lowest point. So just a little thing from there. Now another thing that I hadn't really considered, but it's also like, where does private property start and where does private property not start? So this one here is from Wikipedia, and it's got for the states of Texas and Florida in the Gulf of Mexico and from the Commonwealth of Puerto Rico. For these states, private owned uplands can only start from the mean high water line. So state owned tidelands is between that particular point. In fact, I think state owned, well, I suppose that tidelands, but they own everything out to the water out here anyway, up to the economic zone and the territorial seas. So what that means is that when the water's down at mean low water mark or somewhere there, you can wander in front of all of these rich people's places because you're actually on, or you're not on private land. Their private land is stopped there. Now, on these other states through here, Maine, I presume, and whichever one thinks of Virginia, they start from the mean low water. So you're going to have to get your feet wet if you want to walk in front of their places, in front of the stuff. And then you see their chart datum is the lowest low water ones that they've got through here. So you've then got these, so that state, so on these ones, state owns here and private starting from the low water mark. And then you've got your storm surges which have come up through here, stuff there. And then you've got your territorial sea. Oh look, they've got a 3 nautical miles, which is state submerged lands. I'm not too sure what those are. And then you've got a contiguous zone, and then you've got territorial seas, exclusive economic zones, and then you've got the high seas that belong to everybody. But this is interesting because in England and in some of the Commonwealth countries, they actually have a thing called a Queen's Chain, and that's I think about 6 feet or 6 meters, or I can't remember, around all of the coastline and around waterways like rivers and lakes, and that's called a riparian right. Is it allows people to get to the water to be able to use that water, so it's not totally somebody else's property. So all water bodies actually have this riparian right about them, so that's quite an interesting thing. I'm not too sure whether New Zealand did. It did actually have that Queen's Chain, and I need to do a little bit more research about that. But it was just the idea of the property and the fact that the tides are defining where property starts and doesn't stop. So, if you get some subsidence and the water encroaches in, does that mean you've just lost a whole lot of property? I suppose it does. So some things there. So just some concepts through about that. Now the second thing that I want to do on here is actually just talk about some tide tables and stuff. So what we can do is that we can go into here and we can say, I want to grab this bit of data through, no, I want to grab something there. So we'll grab that bit of data through there. So we can inspect the element and we get our thing. now you see how this changes to a different format. So it's now gone into a concertina. So I'm just going to grab that particular one through there and go inspect element. Now this is a dynamic website. That means the data is constantly being updated from a database. That means it's not static and it's not sitting there. So if it's not static, we would need to do this. Now I did actually have a little play with another thing through here where I went onto a wiki table and I just got all the data off the table. But when I got all of the data off the table, it's all between tags. So I then have to do a lot of scripting to strip these tags off and then to try and order them by the stuff. So this was a big wiki one, but it's a static. And it was really just testing to see whether the Wikipedia pages or the tables in the Wikipedia were static. That means you can just go through and scrape them, and I can't even remember what the code was I had for that to actually do that scraping. But I ended up with a lot of other messy stuff, so you'd end up having to do a lot of cleaning on the data to get it into the way that you may want to use it later. But you could quite easily target it. But the second way that you could do, if you're targeting a dynamic web page and you're trying to get it from the front end, in other words, you're reaching in and doing it, is that you've got to go onto that page and you've got to find that object, and then you've got to come onto the object, and then you've got to copy its XPath or its CSS path or its selector. So we're going to copy the CSS selector through here. So this is something I was playing with to try and do. So if I just drop that down to there and delete it, and then go into there and just put some quotes, and there's my selector, and I'm just going to go small and leave it at that. So what it says is go through all of these things there, loop through everything, and I'm going to leave that as accordion item down, and we'll see what happens here. We're going to get the Selenium driver, so that's going to open up an instance of our browser. It's then going to go and ask for that URL, so it's going to just open up that URL through there. It's going to wait, so we've got these, I'm not too sure if I'm using those or not. No, they're grayed out, so I'm not using them. I've got one of them in through here, which is actually doing a wait for 10 seconds to allow for the page to generate. So that means bring all the data in from the database, and so it can be refreshed onto the page. And then we're going to go in with beautiful soup. The HTML driver has gone through and got that page source. The soup is going to go through and get that element through there. It's then going to go and find that element because it's got the whole page source, and then it's going to work through those to see if it can get me the data through there. And then it's going to print the data, and then it's going to quit. So if we run this one through here, and this is the thing, I don't particularly like coming in front end. I'm not that successful, and I spend an awful lot of energy without too many results. But this is another place where you can actually get data from, rather than maybe an API or going and looking it up some other way. So it's still getting the information, and it's adding all of these ads and everything else like that. And it's got it, and maybe my pause is too short, so let's just go and wait 30 for that. I've only got the one open through there, so let's just see if maybe that was the issue through there, is that we're not waiting long enough for that page to actually load. So here it's loading the page. Now I've got this so that it's actually showing this page. Whoa, no, that just closed out there straight away. I do that. Oh no, it's still doing. So I'm just going to quit out of that. I was getting a whole lot. Now you can do it headless through here, which means it doesn't actually open up that browser page which it's doing here. It'll just do it in the background, but it still takes the same length of time. And I find this one, doing it this way, is quite... I want to try and get rid of that to see if any of that... no, it still just seems to be dying before it gets there. So I wasn't too successful. I got a couple of smaller successes, you see, and so it's actually just given me some blanks. They said, no, can't find anything for you. Go away. And I wasn't that motivated to really do a lot of learning, because instead of trying to take it from the front end, I've got a previous video on getting weather data, and somebody said, well, no, you actually just come from the back end. So you go into the network tab up here and you click on the XHR and then you refresh the page, and it goes and calls from the data from the database. So you can see all these GET requests. So we're going to look up the largest one through here. Sometimes this GET is hidden like that, so you can actually just get the URL that we can actually just select that data there, copy, and we're just going to delete that one, and then we're just going to paste this one through here. And if we just go into the raw data, you'll see we've got an awful lot of information about tides in there. Now, it's got a couple of things in there. If you just go into the JSON format, I'll just go through and I'll collapse some of these because I know where it is. So at the top level, it's got layout. We don't want the last. It's actually in primary and in slots. We don't want the first, nor left, but we do need the main and the modules. Now this is where in 0, if we come into here, we've actually got tide data, you see. But this is only for the 3 days worth. So I'm going to collapse that one, and I'm going to go into the 1, and if I go into the data, you'll see I've got each day, and then in each day I've got 4 lots of tides generally. So that's the data that I want. So I can now use that descriptor, layout, primary, slots, main, modules 1, and then data is the next one, I think, data there. So if we go into our script through there with the back end, we're just doing a request on that URL that we got for the GET request, and when we get the response, we put it into this. So it's going to pull down the whole JavaScript JSON file. I actually did write it to a file just so that I've got a copy if anybody wants it. Then we've gone into the data 1, we've gone into layout, primary, slots, main, modules, number 1, and data. And we said make that the variable data 2. And then we just put that into a data frame. Once we've got it into a data frame, we can start manipulating it like a table, which is what we actually ended up want to organize it as. So we're going to explode it because it's still in JSON format. We're going to explode it. We're then going to take the tide data, which is each individual one, and break it out into height, time, and type. And then we're going to drop this combined one that has all of the data in it. And then we're also going to get the day column, and we're going to turn it into a date time, because then we can actually get the day of the week, so we can get the weekday from that, and then we can just drop the columns that we don't need. I did try doing some other things on here. I'll actually just delete that because I didn't end up doing so there's no point even mentioning it. And then the other thing was I started to try and do a different table, but it was taking too long. What I wanted to do was try and get the inside the data frame, organize the data in such a way that you just pulled it straight in to the CSV to PDF, so that the data was already formatted in the right configuration so that it came in. But it ended up being a bit messy, and I suddenly thought, no, too much energy into that. So when I run this one through here, we're running, yep. Okay, this one's gone through, done the API request, and it's going to dump the stuff into a CSV file. And the CSV file name is 1.csv. So we go and look at the 1.csv, 1.csv. There we are. So there's our data. And we got quite a lot of it, so 125 rows of that. The other thing which I ended up doing was I suddenly thought, well, I've already got the CSV to PDF as a different script that I'd already built up with the other ones. The only problem was my head things were slightly different. So instead of this was called height, this was called time, this was called something else, I can't remember. type, I think. And so I just had to rename the heads of the columns in that data coming through. And then once I've got it into that format, I actually had to change when it did. I think I actually had a 0 and a 1, and then to check whether it was low tide, it's just got to say low instead of, and high instead of 0 and 1. And so it creates the new table. So this is one where I'd actually just use a template. It goes through, does a whole lot of tidying to figure out whether it's got a high tide, low tide, and all of that sort of thing, and all the logic through there. And then it just draws a PDF, and we use the existing one. So it reformatting the data into this type by linking things together, and it makes the same table. The only problem, the only thing is, this table is for 31 days, whereas I think the other one was for, how long was the other one for? 10 days, I think. So this has the stuff. And the other thing which I added on here is I added on a 3-letter day. I did try and get it to act on 2, an upper and a lower, and then I sort of just suddenly thought, no, that isn't really, it's the same learning that you've had before, so that sort of things is there, the data happens. So I'll put these 3 things through there, plus the backup files, the CSV and the JSON files, which was the original JSON file with all that data in there, so that you can play with it yourself. And I hope you found that of interest. If you did, please give a thumbs up. If not, I'll pan your heart. Thank you very much for watching.